Welcome to part 3 of the K&T vertical mill head mount construction video. An upgrade to Windows 10 caused some software issues which gave me headaches till I found a patch for it. Finally got things working again. So I'm back in business hopefully. Here I'm just mounting the 4-jaw chuck back on the lathe, and it really is about as heavy as it looks. I need to find a better way to pick that thing up and get it on the lathe. And speaking of heavy things, getting this slug mounted in the chuck was a little bit more exciting. I need to get a fancy gantry crane like some of the guys have to handle pieces like this. But getting it up there in the 4-jaw took a little bit of work, and trying to do that with the extension on a ratchet did motivate me to make a new wrench for that 4-jaw chuck, which you'll see later in the video. I think this is only the 3rd or 4th time I've had the 4-jaw mounted up, so I'll spare you my efforts of most of my efforts anyway of getting the part centered up in the lathe. I should go back and look at the original video and see how long that was. I never bothered to check, but probably longer than I'd ever want to admit. So now I tried to carefully face it off so I could get a center drill in and get a center mounted to hold that. It's hanging out about, I think it was about 9 inches at that point. So I tried to keep the cuts light and get it faced off to where I could get it supported a little bit. And as you can see, I need to do a better job of selecting inserts to get that chip to break. Well, if I ever got to break on this one, it was got pretty bad. I had to stop the feed occasionally to break the chip. So part of the problem with running an old lathe with a top speed of 478 RPM is carbide. Not ideal setting for carbide, but works sometimes. Now that I've got a live center in there and got a little bit of support on the end, I started getting the OD turned down to the final diameter that I was shooting for. So now that the one end is down to the final OD, we'll go ahead and flip the part around in the chuck and get the other end turned down, faced off, and then turned down. Hopefully you all noticed the following John Mills or double boost advice, and always keeping a board on the ways when I'm changing stuff around. Unfortunately, this lathe came out of a university shop, UCLA's nuclear engineering, according to the guy I got it from. But apparently not everyone was so careful with it all the time. It does show some marks right up there near the chuck, but doesn't seem to cause too much trouble. I'm not sure where I saw these aluminum jaw protectors that somebody showed them, and I just made up a set to fit my jaws. Or just in 1 inch strap, 1/8 thick, 1/8 of an inch thick, just bent around to fit over the ends of the jaws, and seems to do a pretty good job of protecting the finish on the work that's already done. I don't know why I worried about it so much. It's going to get welded and painted, but it seemed like a good idea at the time. Now this one, it does seem to go a little better. but I can see how a little bit of regular practice would sure make this process go quite a bit quicker. If you ever watched Adam Booth do a part in his forge out, it's pretty amazing to see how quick he can get that dialed in and ready to go. After you try it, you have a lot more respect for what he's able to do. All right, now that we've gone through that, I'll bring you in so you can try and get the light off that thing so you can see it. It's running within 1,000th of true, which is probably way better than needed for this, what I'm making, but it's always good to try and get it in as close as you can. Just put this in to show how the chip control or lack of chip control that I seem to have that gets to be a serious problem to deal with. But I've got some newer inserts that I'm trying that seem to be working a bit better, different geometry and different chip breaker styles. I recently went to a machine auction and picked up a couple of different tool holders, WNMG and then DNMG and a couple others, and been trying those out and seem to be getting a lot better chip breaking results with those other tools. I suspect it's that they have inserts that are good quality and not just what was cheap on eBay, which is what I've been running up until now. I can get this faced off and then get a center drill in and get the center on it to start working on the OD. It does hang out there a bit, so like I said, I tried to take it pretty easy on the cuts until I got the center in, and then I was taking pretty heavy cuts, 100 to 200 thousandths per side, so 2 to 400 thousandth total diameter, depending on how bad the chip buildup was getting. On this, I tried to put a towel down or a shop towel down to catch the rusty scale that was coming off this piece. It was just the rust and mill scale. It's a piece of mystery metal from my favorite freight damage supply house. It's pretty good, turned pretty good, and gave a pretty good surface finish, but did have a lot of scale on it. But I'm not sure that having a towel is a good idea or not with the chips I was generating. And then we're going to go wiggly handheld to just give you an idea of the horrible, nasty chips that were coming off this stuff. Like I said, you can see that they're not breaking at all, and they definitely didn't want to let them accumulate in the chip tray either with them all. So this is the pile I've got after working down the stuff from the previous two videos, and then this piece I'm working on now. And before I'm done, there'll be plenty more. Ended up pretty happy with the surface finish and the seam between the two where I'd flip the part around, was you could catch it with the finger now. It looks a lot worse on video, but it was hard to pick it up with your finger. And here's the problem with designing on the fly. I decided wanted it narrower than in order to fit on the column. I had to narrow it up a little bit, so hacked at it with the bandsaw for a bit. I have since got a much better bandsaw blade that makes a big difference. I bought some Storrick blades. I know that you see the nice new chuck wrench there to make life better, so I've got to get it back in and trued up. Now that it's turned to the final OD, I had to work on getting the in near the chuck trued up, as well as the end that was hanging out trued up. That was the phone. Give a prize to anyone who can figure out what the ringtone's from. But here we've got it turning pretty good if you can keep it far enough away so the jaws don't hit it. But a little more run out towards the end. And then I was willing to put up with, so see if we can work it around. Another one of my trips to the freight damage store. Found a nice little lead hammer, and it sure is nice for knocking things around in the chuck. I've used the plastic death blow hammers for years, but I really like the little lead hammer. It seems to do a good job, and it's got a good mass to it for knocking things around. Now that it's knocked in, come in and see where it's running. Helps if you keep it far enough away from the jaws that they don't whack it. They're running pretty good on both ends. I've got to face off the horrible bandsaw cut, and that was again had to take light cuts with the, especially with the interruptions on that horrible bandsaw cut. So now I look at this and decide if the finish was good enough for the finished product. It'll go inside and bear on the sides of the mount to give the tilt forward and backwards to the vertical head. I decided it was good enough and decided to throw a chamfer on it and call it good. Now I'm starting the groove. I'm using the same. I started out with the same tool I used on the 8-inch round for the mount that mounted directly onto the vertical head. With this smaller diameter piece and the smaller radius, wasn't getting it to cut as well, and tried honing it and grinding it a little bit differently, but just couldn't get it to cut as well as it had cut on that other piece. Again, using mystery metal, but the two different pieces were probably some different grade of metal, and this one didn't like that grind nearly as well as the other one did. I tried honing it and getting it to cut, and it does a little bit better, but I think I ended up going through a couple different tools. I'll show them later. It's cutting, but it was requiring a lot of feed pressure in on the carriage feed, and didn't like how much pressure it was taking to get it to cut. So came up with a little boring bar and ground a little bit of relief on it, and decided we'd give that a try. And seemed to work a little bit better, but I still came up with a different way that towards the end it seemed to work the best for this smaller diameter. That squeal was way worse in person than it is on video. This groove gets plunged in 600 thousandths deep, so it goes in there a ways, and trying to check to see if I'm on centering. Quick and dirty centers you faced off the pieces to go in and check the center mark where you've gone in. There's usually a nice little, not necessarily a pip, but a little dot in the center where it centers out. It makes a nice way to check your center, the height of your tool. I believe this is the what do I do now moment. So I pulled the tool off, reground it a little bit, decided to try it again. For some reason I didn't or video or lost the video of the getting the groove cut, the T-slot cut on this side. Fortunately, I did get some video of doing the other side. Well, fortunately or unfortunately, depending on how long this video has ended up so far. So now, like I said, this project got me a lot of practice in using the four-jaw, and actually it was a good experience. A lot more comfortable with it now than I was at the beginning of the project. Actually pull it out and use it occasionally, although like I said, I need to get a better way to get it on and off the lathe, because it's a little heavy for doing it too frequently. I ran into another problem. The quill on the tailstock's about 3 inches in diameter. And couldn't get the tool in with the quill up holding the live center. Fortunately, I have this 4MT extension. It's probably 16 inches long. Again, from the my favorite freight damage store. I found it in a box of pins. They were selling it as a pin. I think it was 50 cents a pound is what they were charging for the stuff out of that box. And it ended up being a really good deal for a nice 4 Morse taper extension. And it allowed me to support the work, but still get the tool in there. And then for this one, for this side, the one that actually ended up working the best was a parting tool, cut with relief to fit the curve, and just doing a series of plunges in seemed to work a lot better than the wider tools that I tried earlier. Just using the edge of the extension to get the tool post squared up so the tool running there square to the perpendicular to the face of the piece. You can see this tool takes a narrower cut. Seemed to require a lot less feed pressure, and as you can see, the chips that came off were a lot nicer. It was cutting, whereas the other tool seemed to be doing more scraping than cutting. So this is if you ever need to cut a deep groove in a face, I'd recommend this way over the other ways I tried. It seems like it went far quicker and was a lot less stressful. I guess it's kind of like parting, but you're going in the wrong way. You can see the chips coming off this were much nicer, curling up, and a nice solid chip instead of a more. It seemed like it was more like a scraped fluff. Reminded me of scraping wood with a cabinet scraper. You can get the almost little flowery cuttings coming off. Now I've switched back over to the little boring bar tool. The parting blade, once the groove was established, it kind of, as parting blades tend to do, it wanted to veer off back into the groove and not make a square cut. And so I switched back over, but as you can see, this other tool works great with the groove already established with the parting blade. So that kind of be the way I'd recommend it, is to plunge in, get the initial groove in with the parting blade, and then use one of these other style cutters to get to the right width. So I believe this is the final pass to get to width. There's just kind of a view of the cutter. And now that we've got the groove to the right width and the right depth, I'm going to use the same little L-shaped cutter that I used on the head mount, the 8-inch round. Just reach in and try and get the sides of the T-slot cut to the right width and depth. There's the parting blade tool that I use. You can kind of see the side relief that fit the radius of the diameter of that groove. Like I said, it plunged in and did a nice job of getting the groove established. And here with the L-shaped cutter, just a matter of getting the dials set up and start chewing out that groove. For some reason at this point I had to put on a little more relief under the cutting edge because of the tighter radius. It was kind of dragging a little bit, so I ground a little more relief under the cutting edge. That seemed to fix the problem, and we're getting pretty good chips off without much rubbing. With the outer edge of the T-slot cut, I've got to go cut in reverse to cut the inner one, so I've got to remove the extension and get the tailstock back, and see if I can get you set back on where we can see, and then I'll go to the far side of the part and cut it in reverse. This was just so I could avoid having to grind two tools, one for the either side of the T-slot. I believe this is how Gary Storrick did his adapter plate for the slaughter head he mounted on his mill. And as I recall, that's where I got the idea, and it works out great. Here's a close-up of the T-slot, and just had to finish up with a couple of chamfers on the edges of the slot. The last step for this part is to drill and tap for the center pivot that the head will tilt front to back on. There'll be 3 bolts in T-nuts, or in the T-slot, and then a center bolt. It's the pivot for the head. That's the idea anyway. And here I'm just drilling and tapping for that center pivot bolt. Here I'm using some crappy offshore tap handles to try and get this tap in it. One of these days I'm going to break down and start looking for some good ones. I get envious watching some of those guys, some of the real machinists on YouTube, and their nice green-filled tap handles, because this certainly isn't one. I think, as I recall, this one came apart halfway through, so I ended up switching out. There's the bigger one, because the other one crapped out, quit working, so I had to switch to this bigger one to finish up the tapping job. So here's the finished product, ready to move on to the next step. I think I've spent more time getting this video edited and put together than I spent making that part, which is pretty sad, because I certainly didn't make the part very fast, and the editing went really slow too. But I am on Windows 10 now and got updated programs, and hopefully everything will be working better from now on. And I appreciate you taking the time to watch. Hopefully it wasn't too painful to sit through, but we'll get the next one. I've got the next video started and get that finished up and narrated, and we'll get that up and get the side plates made in that one. Thanks for watching.